Hi, I'm Fernando, and in the last class we saw how to solve control flow analysis. That's not a very simple static analysis. Sometimes we can recover much information from a program without having to solve such a complex analysis. And today I will explain you some of these heuristics. First thing, we have assumed that every function can be bound to every variable. In a statically typed language, that's simply not true. Types restrict the bindings that are possible, so we can eliminate several constraints like t is in R of x, whenever the type of t and the type of x do not really match up. This observation is the key idea in the paper about type hierarchy analysis. For instance, we have this function apply in this example here. The type of fn of x is x plus 1 in SML. The language that we use here is int to int. That means that the type of whatever comes out of f of n in apply must be int. So v2 could not be used to replace f, for instance, because this function returns a string. We can also use some aspects of object-oriented languages to avoid running control flow analysis. Here, we want to know the possible candidates to the dynamic type of each object. So when we have a method call like o.m, the question is, what are the possible implementations of m? The first obvious approach to answer this question is simply traverse the entire program and find all the methods that have this name. The name m. We can improve that even more by considering the signature of m instead of only its name. As an exercise, try to figure out what are the possible implementations of set x in this program. Consider that we are using set x with only one argument. And we can improve this one notch further by restricting our research for implementations of m to the scope of classes that could be the type of the object O. This works well in statically typed languages that use classes to define objects. And we can do even one thing more. Restrict the search only to those classes that are effectively instantiated in the program. So we end up constraining our search quite a lot. That's the key idea of the paper Fast Static Analysis of C++ Virtual Function Calls from 1996. And that closes our class on control flow-based analysis. These are the key papers that I've cited in this last 5 videos. And there are more references in the course web page. Thank you.